So welcome back everyone. Welcome for another video. This is ECE23 Module 5 Performance Task Introduction to Digital Communications. This is yours truly, Restart Arabal ESECE3C. Cpfsk or Continuous Phase Frequency Shift Keying. Topic to be discussed: Continuous Phase Frequency Shift Keying. Cpfsk works or operates an sample of electronics or technology that uses Cpfsk. Continuous phase frequency shift keying, a commonly used variation of frequency shift keying, which is itself a special case of analog frequency modulation. FSK is a method of modulating digital data into a sinusoidal carrier wave, encoding the information present in the data to variations in the carrier's instantaneous frequency between one of two frequencies, referred to as the space frequency and mark frequency, 0 and 1. In general, a standard FSK signal does not have continuous phase, as the modulated waveform switches instantaneously between two sinusoids with different frequencies. As the name suggests, the phase of a CP FSK is in fact continuous. This attribute is desirable for signals that are to be transmitted over a band-limited channel, as discontinuities in a signal introduce wideband frequency components. In addition, some class of amplifiers exhibit nonlinear behavior when driven with nearly discontinuous signals. This could have undesired effects on the shape of the transmitted signal. So why CPFSK? An FSK absorbs switching from one oscillator output to another in successive signaling intervals result in relatively large spectral side lobes outside of the main spectral band of the signal. So we have seen here oscillator 1, oscillator 2, 1, 0. At this point, we have here discontinuous phase generate unwanted spectrum. So this is not continuous. So why CPFSK? Continuous phase frequency shift keying is a memory-based modulation scheme in which phase is constrained to be continuous. So at this point, we have here 1, 0, phase continuous FSK. So we have here a sinusoidal wave, continuous, unlike the other one. It have a discontinuous at this point. At CPFSK, the signal is continuous as shown in the figure. So next, presentation of CPFSK. A sub n information sequence 1011, I sub n sequence of amplitudes obtained by mapping k-bit blocks of binary digits from the information sequence A and into the amplitude levels positive negative 1, positive negative 3, and to positive negative m minus 1. G of t is pulse shape. Example, rectangular pulse of amplitude 1 over 2t and duration t seconds. D of t is used for frequency modulate the carrier. We have here the formula. V of t, the equivalent low-pass waveform. We have also here the formula. F of d is the peak frequency deviation, and pi 0 is the initial phase of the carrier. The carrier modulated signal corresponding represents the time varying phase of the carrier. So we have here the formulas. Next. Although d of t contains discontinuous, the integral of d of t is continuous. The phase of the carrier in the interval. So we have here the formulas. Note that the g of t is assumed to be rectangular pulse of amplitude 1 over 2t and duration t seconds. So we have here the formulas. H is equals to 2f sub d t. The parameter h is called the modulation index. We observe that the theta sub n represents the accumulation or memory of all symbols up to time n minus 1 times t. So we have also here formula for the CPFSK, how CPFSK operates. So sample or electronic technology that uses CPFSK. So is used for communication systems such as telemetry, weather balloon radius sondes, caller ID, garage door openers, and low frequency radio transmission in the VLF and ELF bands. A color identification, modulating apparatus and method using multiple thresholds. An apparatus according to one impingement comprises a zero crossing detector for generating pulses at points where the modulated color ID information crosses zero and outputs each pulse as a zero crossing signal. A data extractor for computing a zero crossing interval between each output pulse of the zero and comparing the crossing interval with a plurality of thresholds to generate extract data, and a clock generator for generating a data recovery clock signal for recovering the extracted data in response to the extract data, wherein the data recovery clock signal is enabled at the middle point of the unit data length of the extracted data. The apparatus and method use multiple thresholds to extract data from color ID modulated in a Cpfsk format, thereby accurately extracting data at interval where data 0 and 1 coexist. Furthermore, the clock signal for the modulating extracted data is generated about at the middle point of the unit data length of the extracted data, thereby modulating data accurately. So, the example of CPF is FSK is a color identification. So, that's all for this video. Thank you and see you next for another video.